So today we're going to wrap up section 1.3, which is the final topic, factoring. Now this is actually a very big topic, and I highly suggest you, after this lesson, you actually practice some. So factoring, we know what factoring is. It's the opposite of expanding. We're going to break our building blocks into smaller little pieces. So the first method, the main method that we're going to talk about actually, is called the guess and check. Normally, well, I'm not even going to say normally. This is in particular for trinomials. And if you recall what the word trinomial means, that means three terms. And if I play with my exponents right, that's going to be x squared. One of them is going to have a single degree of exponent 1 and a constant, namely. Those are some easy examples. So, guess and check method. That's what we need to do with factoring. There's a guess and check method. So, the first one I want to do is x squared plus. Oh, let's actually get some motivation real quick. So let's suppose I have x plus 3 times x plus 5. If we were to multiply these guys together, distribute them out, of course, you would get x squared plus 8x plus 15. This is what you would get once you combine like terms and all that good stuff. So now we have to have some reasoning. Where did this 15 come from, and where did this 8 come from? Well, notice that the factors of 15 are 1 and 15. Of course, we're going to find the factors because the whole problem is called factoring. 3 and 5. These are our only factors off the bat. Now, how do I know if I'm going to use 1 and 15 or 3 and 5? They both multiply into 15. What other conditions or what other part in my expansion do I need besides 15? Well, I also need this to be 8. So which one of these combinations right here or here would somehow add up to 8? If you said positive 3 and positive 5, you are good to go. So the way we actually factor that is we're going to write two factored expression. Remember, factor means multiply. So we're going to have two giant objects multiplying each other. I know my factor has to be positive 3 and then positive 5. I know that. Great. Now I just need to figure out this final piece. Well, the final piece is just going to be whatever times this would give me x squared. And it has to have an x. What that means is that both of these actually have to be x. Not only do I have to have an x there, however, not only do I have to have an x there, but they also have to multiply to x squared. So this has to be x times x. It can't be x times 2x. It can't be x times 3x. It has to be x times x. And when we factor, normally we don't talk about fractions. So that's why we're choosing x times x instead of 2x times 1/2 x. Okay, so let's do another example. This could be example 1. This is called the guess and check method. Why is it called guess and check? Because we got to guess our factors. And then we check to see if it works. It's not really a guess, but we call it the guess and check method. So let's try another example. Let's do x squared. Let's do, oops, let me write it below. Use a different color. Let's do x squared minus 60. And then we're going to do plus 4x. Well, in this case, when we're doing our guess and check method of this trinomial right here, this is minus 60. So we get the factor of minus 60. Oh, we have to get the factors of minus 60. Those are a lot. We got 1 and 60. We got 2 and 30. We got 15 and 4. We got 3 and 20. There's so many different ones. What else am I missing? 10 and 6. That might be it. There might be other ones, but these are the main ones right now. I think 12 and 5. Let's do 12 and 5. 12 and 5 also works. Now, notice that this 60 is negative. What that means, if we're multiplying things out, one of them has to be negative and the other one has to be positive. I don't know which numbers are positive. I don't know which number is negative. But one of them's got to be negative, one of them's got to be positive. So, thinking about that, which combination of these factors would somehow add up to positive 4x? Well, 1 and 60, there's no way that can happen. 2 and 30, there's no way. The gap is too big. 15 and 4, the gap is still too big. 3 and 20, the gap is still too big. However, 10 and 6, that could be a possibility. It might or might not. Somehow, I have to get 4 out of 10 and 6. So let's already write our factors down. Well, this is positive 4. One of these guys has to be negative because we have negative 60. Which ones have to be negative to somehow get 4x? Positive 4x. Well, because it's positive 4x, the bigger number has to be positive in this case. So we're going to have plus 10. And then the negative number is a smaller one, minus 6. And the reason why is because our answer over here is positive. If it was negative, the bigger number would have to be negative. Because 10 plus negative 6 would give me positive 4. That is the reason why this works. And then same situation. Hey, there's an x here. There's an x squared. I know I have to have an x in there. But I also know the two terms over here have to multiply into x squared. Well, that's going to be x times x. Boom. We did our second example. So mainly, I'm going to show you a lot of different examples. Let's do another example. This time, I have x squared plus... And notice that all of these examples I'm giving you, there's only a 1 here. I haven't discussed what happens if the leading coefficient, which means the number in front of the highest exponent, is more than 1. I have not discussed that. That's for a different time. Right now, we're just doing if it's a single 1. So, let's do... what was I doing? I forgot. Let's do plus... let's do 12. And then we're going to do 7x. Well, this one looks funny. Because if I do my factors of 12... I get 1 and 12, 2 and 6, 3 and 4. These combination. So instantly, when you look at this, the only possibility it can be is 3 and 4. Sometimes it may or may not be factorable. However, this is a negative 7, so I'm confused. I have to somehow get positive. I have to somehow multiply something, figure out what multiplies to 12, positive 12, but also adds up to negative 7. That's weird. Well, draw my factor. Recall that a negative times a negative is a positive. So in this case, we can have negative 3 times negative 4. So I'll put that down because negative 3 plus negative 4 is negative 7. But if I multiply them, my answer is positive 12. So we're going to have minus 4, minus 3. And it's the same exact scenario. We have the x's here. Boom. That is it for that third example. And I want to do one last example for this method in particular. This is also called, this next one, even though it's part of this method, some people call this a perfect square. They call this the perfect square, but it is still the exact same method. Boom. Perfect square. X squared minus 16. Well, how many terms do I have? I only have 2 terms. I don't have 3 terms this time. So things are going to be a bit different. Or are they? Technically speaking, if you see 2 terms only, this is the exact same thing as saying x squared. Well, it's missing that x by itself, isn't it? So why not put 0x minus 16? Because 0 times any number it disappears. Remember, I told you in this class we're going to play with zeros and ones a lot. Well, now if I do this problem, Negative 6. Find the factors of negative 16. 1, 16. 2, 8. 4, 4. And that should be it. What combination can add up to 0? Where one, because I have negative 16, one of them has to be negative, one of them has to be positive. Which one of these add up to 0? Well, if you guess the negative 4 and positive 4, you got it. So technically, this is going to be x minus 4 times x plus 4. Oh, that's interesting. So we're able to deal with binomials as well. We're able to use this method with just 2 terms sometimes. The only times you can use this, notice that, hey, this is x squared. These guys are x. We call this perfect square because if I square root x squared, I get x. If I square root 16, I get 4. That's why we call it a perfect square. So in your book, it's going to say that perfect squares are in the form of a squared minus b squared, which we can factor out to be a minus b, a plus b. This is what your book will tell you. It's fine as long as you understand it. Perfectly fine. So notice that this is a subtraction symbol. I did not do x squared plus 16, which in fact, this doesn't factor out nicely. This doesn't factor out nicely until we get to chapter 3. So if you see a plus sign here, that's a no-go for now. Until we get into complex numbers. So this works out nicely. And then we can do stuff like x squared minus 25. We can break that up into, using the same rule, we can square root this x. Boom, see a squared. We can square root that x to x. And then boom, boom. And then we can square root the second term, minus 25, which can give us minus 5 plus 5. Boom. So it's that same idea. Now, you can do the guess and check method where you put a 0x in the middle like I do. That is just for me to show you why this works. This didn't just come out of thin air. Now, moving forward, that's called perfect squares. So we can do that using the guess and check method. Now, an exercise I will give you guys. This is a bit more challenging one, unless you use the property you just learned. I challenge you guys to try out. Where is it at? Try out this one right here. Let's see. Boom, 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 boom. Try out 4x squared minus y squared. This time, I don't have a constant for the second term. And I'll give you a hint. Oops. You can use the hint. The middle piece, if you think of it, it should be 4x squared. And you could do plus 0x squared minus y squared. Oops, not x squared, I'm sorry. Boom. You can think of it this way. Or y. Yeah, you can think of it that way. And then, this is the hint. Sorry about that. The pen's dying out or something. That's the first exercise I want you guys to give it a shot. The second exercise I want you to give a shot is this problem right here. Let's see, where's that? Where did I put it? X to the fourth plus 15 x squared plus 54. This over here. So I want you to give this a shot. Hint. The hint I'm going to give you is treat this like a trinomial. It is a trinomial, but treat it like a trinomial guess and check. That's my little hint there. Treat it like the guess and check. And then you'll see something. The only thing you got to really worry about is these exponents. They're a bit different, but you guys can figure that out. So, the next form of factoring, one of the most important ones, is going to be called GCF, which stands for greatest common factor. So recall that factoring is pretty much components of multiplication. So I need to be able to find GCF of, let's take x to the fourth plus x, well, let's do 3x to the fourth plus x to the third power. Well, if I re-represent this as factors as much as possible, this is the exact same thing as saying 3 times 1 times x times x times x times x plus x times x times x. Correct? Now, what kind of factors do they share in common? They share x. That is it. I mean, you can argue 1, but for now we don't really care about 1. But they share an x. How many x's do they share in common? Well, there's 3 x's here, there's 3x. Do they share 4 x's in common? No, because this one over here only has at most 3 x's. So we can say the greatest common factor in this one right here, in this problem, the GCF is going to be x cubed, because x times x times x is x cubed, which means that we can actually rewrite this guy as x cubed, our factors. We're going to break this down into those building blocks now. I can break this down into x squared times my remaining pieces. So if I were to pull out an x cubed from this guy right here, from this guy, well, I'm just pulling out x's so the 3 stays the exact same. If I pull out 3 x's from 4 of those x's, I'm left with a single x. And then there's a plus sign here, so I'm going to put plus sign here. Now, if I go to my second term, if I pull all 3 x's out, which means divide because it's multiplying, what am I left with? It is not 0. Remember, 0 only happens when we're doing addition or subtraction. This is multiplication that's happening on the x's. This becomes a 1. So this is what the factored version is. This is factored. This is my factored form. Boom. You're going to have 3x to the fourth plus x cubed transform into x cubed times 3x plus 1. And you can multiply them out to see if they give you the exact same answer. That is GCF. So let's do another example of a GCF. So, find GCF. Let's do 20 and 16. What is the GCF between 20 and 16? This time I didn't put any variables down. I want to break this up into, something that looks like distributive property as much as possible. Well, 20 can be broken up into 2 times 10, 5 times 2, boom. And then 16 can be broken up into 4 times 4, 2 times 2, 2 times 2. And then if we think of it like our prime numbers, we have 5 times 2 times 2 plus 2 times 2 times 2 times 2. Now, this is a for sure way of getting your GCF. By the way, once you get comfortable, you do not have to do what I'm doing. So the GCF between 20 and 16, well, they both share 2 2's in common, which means I can pull out a 4 because 2 times 2 is 4. Boom. I can pull out a 4, and then if I take out a 4 from the 20, that's going to leave me with 5. And when I say take away, I mean divide. Boom. Because the opposite of multiplication is division. Then plus 4. Because there's two sets of 2, or two 2's over here. So we can break up 20 plus 16, and the GCF is going to be 4. GCF is 4. And if I actually write it in factor form, it's going to be 4 times 5 plus 4. And this should work. Which 5 plus 4 is 9. 9 times 4 is 36. 20 plus 16 is 36. So this does check out. This is how you find a GCF manually between two numbers. Once you get more practice, you'll get better at it. The better idea of thinking of GCF, think of what divides 20 evenly. What is the largest number that divides both 20 and 16 evenly? 4 divides both 20 and 16 evenly, and it is that largest number. So, now that we can do with numbers, let's put a mixture. Let's do 20xy squared plus 30x squared y. Oh, find the GCF. Factor or factor. I'm just going to say factor. Factor. In this problem right here, it is very difficult to factor by guess and check. So we factor by GCF. Well, 20 and 30, if you practice this enough, your GCF between 20 and 30 is going to be 10. Now, there's a single x here. There's 2x here. At most, I can only divide by x to both. At most. So x goes out here. Now look at the y terms. Well, this has a single y. This has 2 y's. At most, I can pull out a single y without going into negatives or anything like that. So we got 10xy. Now, this is all going to be multiplied by whatever is remaining. So let's look at the first guy right here. If I divide that entire thing by 10xy, 20 divided by 10, that's going to give me 2. X divided by x, well, that's just 1, so that's gone. Y squared divided by y, that is just a single y. And then keep the plus sign from over here. And then we do the exact same procedure for the second term. 30 divided by 10, that's going to be 3. X squared divided by x, that's going to be x. Y divided by y, that's 1, so it is gone. This is our factored form. So now we are able to turn this long set of building blocks into smaller ones using GCF. So we have the guess and check method, and that also works for perfect squares. And then we also have the GCF method. Guess and check and GCF so far. So that's very nice. Now, sometimes in problems, things don't work out that nice. Or sometimes in problems, you can do a bit more. You can do a bit more. You might be able to do so in a problem. You might be asked, hey, factor completely. Sometimes you have to break them up more than once. Example, let's do x cubed plus, well, let's just do, sorry about that. Let's do 2x squared plus, let's see, boom, boom, 10x plus, what is that? 6. I want to say 6, but I don't want to say 6. Let's do 12. Boom, let's do this. Well, over here, I've never told you how to deal with this guy right here. I've never told you how to deal with that. So that's very difficult. When I've told you how to deal with it if there was a 1 in front of the x squared, but not if there was an actual number bigger than 1. So, already you can't do guess and check. However, you can do GCF if I throw in, let me see, boom, boom. I can do the GCF method. And if I pull the GCF from these 3 terms, we figure out that the GCF is 2. So if I pull out 2 from all 3 terms, I am left with x squared. Remember, when I pull out, it's just dividing, plus 5x plus 6. Boom. Well, great. Now we've factored it out. However, this is not factored out fully. Why? Because this looks familiar, doesn't it? How much terms are there? There's 3 terms, so it's a trinomial. Well, guess what you gotta try out with a trinomial? You gotta do the guess and check method. So, the factors of positive 6, we need to figure out the factors of positive 6 that adds up to positive 5. So, the factors of 6 is 1 and 6, 3 and 2. Which combination of this would give me, oops, this is supposed to be a 2, would give me 5? Now, you might argue, hey, what if 1 and 6 were negatives? One of them was negative, one of them would be positive. However, this is a positive 6, which means you either have to have both factors positive or both factors negative. So if both factors were positive, 1 plus 6 is 7. That is not 5. If both factors were negative, you would get negative 7. So we can't do 1 and 6. However, 3 and 2, if they were both positive, would work out nicely. So if I factor this out, and I'm going to use brackets now. Brackets are the same thing as parentheses. It just makes it look, it just cleans up your problem for any algebra. So if I use brackets here, I have x. Oops, erase that. You have your factors in here. We're going to break up this piece right here. And if I break up this piece, well, we know we have a positive 2. We have a positive 3. And like I said, this is x squared and x. We know we need to have an x. And we know we need to have something that multiplies into x squared. So clearly this is x and x. Boom. That is our expression once we factor it out fully. Boom. Factored out completely. So I encourage you guys to try this exercise here. Oh, 40 client. What is that? I don't know what that is. Ignore that. So I encourage you guys to try this exercise right here. Try out x cubed plus x squared. Oops. Minus 17x squared plus. Let's do 72. Try this out right here. Now you'll notice this is much different than the problem up here where I gave you guys x to the 4th plus 15x plus 54. Notice that this guy doesn't have an x. You can't do the GCF with this exercise here. They don't have any factors in common. They do not. Why? This doesn't have an x, so automatically it doesn't share anything these guys have. Well, this guy doesn't, his only constant factor is 1. These are 15 and 54. So like the only similarity these guys have at all is 1. Or the only factors they have in common. However, over here, in the problem I gave you exercise, there is a factor that is common among these 3 terms. You got to figure it out. So, moving on. Now, I also want to discuss, some other perfect squares. So we talked about perfect squares if we had subtraction. But there are some other perfect squares that we have. X squared plus 16x plus 64. This is a perfect square. If we guess and check, we automatically have x plus 8 squared. Another one is x squared plus, let's do 10x plus 25. This can be written as x plus 5 squared. These are also perfect squares. Now, we'll go more into that when we talk about completing the square. I just want to introduce that. So the last factoring you guys need to know, or last 2 factoring, I apologize. So I'm not going to go into detail about this one right here. This is factoring, or this is called difference of cubes. Difference. The word difference in math means subtract. And cube means third power. So, difference of cubes. I'm just going to give you some examples of difference of cubes. So, if I have, let's say, let me see, where is it at? Difference of cubes. If I have a cubed minus b cubed. This is the same thing as saying a minus b times. Now we're going to do the perfect square for addition. A squared plus 2ab. And this is going to be minus b squared. Or plus b squared, I'm sorry. And where did I get this form from right here? This guy? Well, that's the exact same thing as this positive perfect square, if you notice that. X plus 5, what is it? 5 times 2 is 10. That's where we get the 2 right here. 2 times whatever this number is. So difference of cube is for cubic values. And then the other one you need to know is a cubed plus b cubed. And that's going to be almost the exact same thing. However, we're going to get the inverse. Instead of a minus b, we're going to have a plus b. And then instead of our addition of perfect square, we're going to have the subtraction version. That is difference of cubes. So try to use this rule. And let's do an example. Example, let's do, I don't know, 16. Oh, I don't want to do 16. Let me see. 27 x cubed. Let's do minus. Let me use a different color. 27 x cubed minus 64 y to the 6th power. Well, if I'm going to do this, I got to follow that little rule right here. So clearly this is a subtraction symbol, so I'm going to use this guy. And it's saying a cubed. So this guy is going to be the cube root of whatever that value is. So this is going to be exactly equal to the cube root of 27x cubed, which is going to be 3x. And minus, now we got to get our b value. Well, that's the cube root of this guy. And that's going to be 4y squared. So let me rewrite this out. This is going to turn into 3x minus 4y squared times if we look up over here, it says a squared, so our a value is 3x. So we're going to get a squared, a squared, which is going to be 9x squared. And then we're going to do add 2 times ab. So 2 times these two multiplied each other. So that's going to be, what is that? So 2 times 3x times minus 4, times 4y squared. Which that'll give us 624 xy squared. And then the last part is going to be plus whatever this guy is squared, which is 16 y to the 4th. Boom. Oops, did I do it right? 16 y to the 4th. Yep, y to the 4th. So that is this expression factored out. This is called difference of cubes. So I just wanted to show you guys that I'm not going to give you the reasoning. That goes into later topics, but you do need to know how to do difference of cube, or at least recognize it at the very least. Difference of cubes and summations of cubes over there. Boom. Now we move on to the last type of factoring. So we talked about factoring completely, factoring guess and check, factoring GCF, and difference of cubes. So now the last thing we need to talk about is factoring by grouping. Factoring by grouping is the last one. So I need to factor this guy right here. X squared plus x squared plus 4x plus 4. And if we notice, looking at this right now, there is no common factor. There is no GCF. No GCF at all. However, who remembers what the associative property states? The associative property states that, hey, if they're all addition, if they're all subtraction, or if they're all multiplication, if they're all one operation, what I can do is I can put parentheses wherever I want. Now, if I put it over here, there's technically a plus sign over here. I can put it wherever I want. And the reason why I do that is because, hey, if I put a parentheses over here, let's see. The plus sign is out in between them. However, this is positive 4x. So boom. So this does matter. It'll play a role later on. So I grouped it up together. I am able to use the associative property to split this up into two pieces. But they aren't multiplying. They are not multiplying. Factoring splits your problem into smaller components via multiplication. So I need to somehow do that. Well, if we look at our first group, we can find a GCF of x squared. We can do that. If I find a GCF of x squared, I get, what is that? X squared. And then we have 1 plus 1. Then I can also find a GCF of the second one. Well, the GCF of that is just 4. So plus 4. The plus sign drop down. Then I get x plus 1. Boom. Nice. So we have that. However, this doesn't play out nicely. It does not. So sometimes you need to rearrange things together. So let's actually rearrange this together and then see what we can get. Oops. Well, that was the... Let me just control Z this. Can I do that? Will it bring it up? Oh, it does bring it up. Let's just leave it like that. Let's just do a new problem now. So that's the factor for... That's how you factor by grouping. That is the idea. You're going to be using the associative property to play around with it. Now, you can also use the commutative property to move around your terms and then group them up differently as well. So, example I want to do with you guys is... Let's try out x cubed minus 2x squared minus 9x plus 18. If I were to group these up, I can group these together. Now, remember what I said about the sign. The negative goes with the 9x. However, technically there was an addition here. There was technically an addition there that existed. So we have to leave an addition there. Now, if I find the GCF for the first one, I get x squared. And then I get x minus 2. Good. If I factored out the second one, I can factor out a 9. Or I can factor out a negative 9. One of them is going to be more useful than the other. One of them will be more useful than the other. I'm going to say the more useful one is going to be factoring out by negative 9. If I factor out by negative 9, I get x minus 2. Why is it more important? Well, do you guys notice that these are the exact same? If they are the exact same, I can factor that out. I can pull that in GCF. I can find the GCF of these terms. The GCF of these terms is x minus 2. So if I pull out an x minus 2 for this term right here, I am left with just x squared. If I pull out from over these term over here, I get minus 9. This is how you factor by grouping. Now, of course, you can factor this even further, which is x minus 3, x plus 3. But that's how you factor by grouping. The idea is, hey, I'm going to place parentheses or group them however I want to, and then I'm going to find the GCF of them. And then I might have to find another GCF to play around with that, like over here, the x minus 2 piece. This will play a huge role in our factoring problems. So, this was actually a hard example. So let me give you one last example to actually try to work with. Let's try to work with 2x squared minus 2x, or minus 2. And then we're going to do plus minus 2x . And then we're going to do 5x squared minus 5x. See? Let's change this up, actually. Nah, I like it the way it is. So this is going to be a little exercise for you guys. Try it out at home. Try to factor this by grouping. And then you'll notice that, hey, I might have to find the GCF twice. You're going to see that. So that is all of the factoring we will be doing in this class for now. So that ends today's lesson. So that covers all of 1.3. And the only thing left is 1.4, which is rational. And I will talk about that tomorrow. So take care, guys. Bye.